In the coming clips, we will spend some time on power series. Well, what are power series? Power series take the following form. They take the following form. So I take any arbitrary sequence an, and an is multiplied by the nth power of some number x, right? So basically a power series is a sequence of partial sums in which the partial sums lead to polynomials, right? In which x is the variable. Okay, one of the, so here an is a sequence in R, and x is also an element of R. Yeah, this is a basic idea of a power series, and one of the more important questions regarding power series is the following. For what x's is the series a n x to the power n convergent? Right? So let's give an example which we can solve this question rather easy. So here we take the constant sequence a n equals 1, and we take the sum for n equals 0 to infinity xn. Yeah, so here we see that all the elements here basically an is equal to 1, right? So this is the resulting power series. And we may ask the question, for what x is the sum of n is 0 to infinity existing over xn existing? Well, we know what this is, right? So if we sum over these powers of x, it is only convergent for x in the interval -1, 1, where -1 and 1 are excluded. Well, why is this? Well, it constitutes a geometric series, right? So, and of which we have seen that the sum only exists if x is in absolute value smaller than 1. Okay, another example. Let's consider the series, the power series, were defined by x to the power n divided by n factorial. The question again is, for what x's can we sum up all these terms? Yeah, for what x in R is this power series converging? Well, we can say something, since we can take here these as x to the power n divided by n factorial. We can define it as a sequence of elements an. And we have just spoken about the ratio criterion, which we may apply to see directly in terms of an whether or not a series is convergent. So let's take an equal to x to the power n divided by n factorial, and then we're going to look at the absolute value of the ratio between the n plus 1th element and the nth element. Yeah, if we do so, we get the following fraction, right? So it's just working out, just plugging in the values for an plus 1 and an absolute value. Then we can simplify, right? So we should have here, I forgot the nth power, we should add it here. Then what we see is that x to the power n plus 1 divided by xn is just x, absolute, right? And the factorials cancel partly out, since we only remain the n plus 1 in absolute value. So we get x in absolute value divided by n plus 1. Okay, the ratio criterion says something about the limit of the fraction of two consecutive terms in the sequence. And we see here that when n goes to infinity, since x is a particular value, x is fixed, that we see that this goes to 0 as n goes to infinity. Yeah, so our conclusion is that regardless the value of x, that this series is converging. So this series is converging for all x's in R.